Okay, hello. Just checking if everyone can hear me, and then probably I will start the lecture now. Okay. Uh, yeah, all good. Okay, so we have a few more students in the lecture. I think we can start now. It's over 10 o'clock. Okay, good morning, everyone. This is Fit 5136 Software Engineering. We are on the week 3 now. Okay. So in this week, we will cover about requirement analysis and object-oriented program. And this is me again, Clark Tantitam Tawan. I'm the CE and the lecturer for this unit. And very nice to meet you, everyone. Okay. Next slide. Okay, so just recap. Last week we talked about functional requirement and the non-functional requirement, and what exactly is the requirement, right? So we cannot build the software without the requirement. We cannot build the house without the requirement. So the requirement basically it is used to describe the characteristics of the software products that we need to meet in order to meet the needs of the clients or the stakeholders, right? So it will describe everything, what the product should be and what is the features inside the software products and what a product must do and what are the general properties of the software system. We talk about functional requirement and the non-functional requirement. When we say that what is the function, what is the features of the software products, right? That's a functional requirement. But when we look at the overall of the software system, that becomes a non-functional requirement. Okay. Yeah, let's take a look at this one by one, right? Let's say the system sends an approval request after the user enters personal information. Okay, so this is basically it describes the behavior, the feature of the software system. So it is the functional requirement. All right. A search feature allows a user to hunt among various invoices if they want to credit and issue invoice. So that's also the same, the feature of the software system. So that's a functional requirement. The system sends a confirmation email when a new user account is created. That's also a functional requirement because it describes the feature, send a confirmation email. Okay, but when we look at the general properties of the software system, right, that becomes the non-functional requirement. For example, the website, everything, the whole thing, right? The website should finish the loading within 3 seconds. Okay, with the total numbers of site and can handle like up to 5,000 user load, that kind of thing. So that's the general properties of the software system or general property of the website. It does not describe what is the feature or the function or the behavior of each web page. Okay. The system should be able, the next one, the system should be able to handle 20 million users without performance deterioration. So again, this is the general properties of the software system, right? And some people also talk, some students also ask about security, right? Security, whether it is a non-functional requirement or the functional requirement. I would say that it depends on the way we write it. Okay, it can be both, it can be one, or it can be another. It depends how we write it. Let's say if we say that the website should be extremely secure and someone and the credit card information cannot be stolen, that kind of thing. So that's more like a non-functional requirement. But if we say that the system should have multi-factor authentication, so the users can log into the system securely, that's more like a functional requirement, because the multi-factor authentication, which is related to the security, is actually one of the feature of the login part. Okay, does that make sense to everyone? Just a recap of about the functional and the non-functional requirement. Okay. So today we will talk about the software analysis. How can we model the software? How can we analyze the requirement? How can we write the use case scenarios? And what is the software requirement specification? And also about the object-oriented programming concepts as well, the basic fundamentals. Okay, analysis. Software, okay, it's not just only one Python code or one Java code, one Java file. It's extremely large. And when we talk about like the real software system, think about mobile banking application, ATM machine. It involves lots of part component inside the software. And for the people who develop it, it may be easy. But if someone develop it and someone else have to maintain it, right? Without a general idea, the high level structure of the software, it becomes even problematic how to maintain it because they have no idea how the software is structured. So when we have high level diagrams of which is and one activity about the system modeling here, it will help everyone in the team understand the high-level structure of the software, how each object of the software is connected together, interact with each other, what is the flow of the usage, the flow activity, how the software will behave, that kind of thing, right? So that's why we need the system modeling. Without such kind of modeling, it's hard to understand the high level because the real software system is extremely complex, right? And to do that, normally people use the UML diagrams, right? So UML is unified, it stands for Unified Modeling Language, which is a standard modeling language, and we're going to use it throughout the unit, okay? Okay, the purpose of the system modeling, we often use to understand the functionality of the software system. Functionality, not the functionality. We cannot model the characteristics of the software system. We can only model the functionality of the software system, how each object interact with each other, what is the use case diagram, what is the flow, what is the activity, what is the data flow, that kind of thing, you know. And during the design, we often use the system modeling during the design, software design part, which is at the beginning of the software development process, right? In order to describe to the engineers how to implement the system, this is what we want, this is a high level, and the engineer just implement based on the design, okay? Yeah, okay. System perspective and the viewpoint. For any diagrams you use, your diagram shall look into this perspective, right? So there are different, when we draw the diagram, there are different perspectives for different stakeholders. It depends who are we communicating with, okay? We can have a diagram from the external perspective as well. For example, we can model how the context and the environment will interact with each other. We can model the interaction perspective as well, how each of the system and the environment will interact with each other, with the component, that kind of thing. Structural perspective, modeling the organizations of the software system, the structures of the data, behavioral. We talk about the dynamic behavior of the software system, right? I think we'll go through this detail later as well. Yeah. Okay, these are some of the examples. An external perspective, right? For example, whether we can design like whether the software is going to be used in which context as well. Probably not indoors and outdoor here. I should say that maybe in mobile devices or desktop application, okay? That's an external perspective. And interaction perspective, is your system part of a bigger system? So we are developing just a library. Think about PayPal API, whether we need some other banking system to interact with us or not, that kind of thing. That's an interaction. How our component, our system will interact with the other environment, right? Do we need to connect the API to the other banking system? What about merchant, like online shopping system, that kind of thing? So that's the interaction. We can talk about interaction within the system or outside of the system as well. Structural perspective, that's more like between the object, right? Object and how are they structured? What is the relationship? What is the association? For example, one customer and one shopping cart. What is the relationship here? Association here? One to many, many to many, many to one, that kind of thing. Okay. Yep. And behavioral perspective, yeah, how does the system behave? Okay, we'll talk about that later. That's why we need the UML diagrams, and mainly, based on the definition, UML diagram is a standard language for specifying, visualizing, constructing, and document the artifacts of the software system, as well as the business modeling as well for another non-software system, right? And mainly UML diagrams have two types. Okay, the first one on the left is the structural diagrams. We talk about the structure of the software system, and on the right side here of this figure, that's the behavioral diagrams. We talk about we use the UML diagrams to visualize the behavior of the software system. Which can be like an activity diagram, use case diagram. We talked about use case diagram before. What is that? The notation, the actor and the use case, that kind of thing, right? State machine diagram, we can also use when we want to document the state as well. For example, the washing machine have its own state, right? Power on, press the button, load the, the liquid, the dishwasher liquid, choose the mode, what is the washing cycle, and press the button on. That's the state of the washing machine. Okay, that's an example. Sequence diagram, we talk about the sequence of the activity again, right? Communication, interaction diagram, timing diagram. There are a bunch of things, but we will not cover everything in this unit. We just cover only some of them. Okay, what are we going to cover today? So these are a few types of the UML diagrams. Okay, when we talk about the activity diagram, what is that? Can anyone answer in the Zoom chat? Structural or behavior? Structural, which type of the UML diagrams? Structural or behavior? Zoom chat, please. Behavior? Yeah, behavior, because we are talking about the behavior of the software, right? How each of the component in the software will behave with each other. Okay, that's the behavior. Okay, it's not about the structural at all. Okay, yep. So for example, this one I assume should be an online shopping cart, right? That's the flow of each activity. Okay, that's the flow. Think about the online e-commerce. The first step, what we need to do, we need to receive an order, fill an order, send an invoice. Okay, once we get the order, we can arrange the delivery tonight or arrange the regular delivery. Think about Amazon Prime. Okay, would that be like a Prime delivery or not, right? And then receive the payment, send the invoice, and then all done. So that's the activity diagram. Okay, use case diagram. Okay, behavioral or structure diagram. Yes, again, behavior, right? Because we talk about how the actors and the use case interact with each other. Okay, so that's the use case. Think about this one again. Okay, online shopping system. We have who is that? Customer as an actor, the initial actor, right? And then we have a few numbers of use cases where the customer can view the items, make the purchase, complete the checkout, and log in. Okay. And we also have another external actors as well. Okay. What is that? What is that? The external service, right? Authentication, and identity provider, credit card payment service, and the PayPal. Okay, so that's what we summarized in the last week as well. And by the way, yep, okay. So anyone who joined the Zoom, yeah, please mute as well. Thank you so much. That's a use case diagram. Thank you. Class diagram, is that the structure or the behavior? Yeah, structural diagram. Yeah, because we talk about the structure of the software system, right? One software system consists of multiple components. For example, what is this here? The ATM. This is an ATM, right? We have the bank, probably the branch, okay, the bank account, the branch ID. We have the customer class. We have the account class. We have the ATM location. We have the ATM transaction. We have the account, current account. We have different types of the account here, okay? Current account, saving account, transaction account, that kind of thing, okay? So that's a structural class diagram, right? We talk about the structure of the software system, and we use the class diagram to describe the association between the objects, between the classes here, whether it is one-to-one, one-to-many, many-to-one, or many-to-many. Interaction diagrams, okay, structural or behavioral? Zoom chat, yes. Yep, behavioral. Okay, so interaction diagram is also part of the behavioral diagram, right? So because we want the interaction diagrams to describe the flow or the interactions of the objects, we didn't talk about this, what are that objects. If we talk about that objects, that the class diagram, or which is the structural diagram, right? Structural types of the UML diagrams. But the sequence, the interaction diagrams here, it describes the flow, how things are interact with each other, okay? There are different types of the interaction diagram. I think one of them is the sequence diagram, which is this one. So basically we describe, visualize the interactions between the objects in a time sequence. Okay, that's a keyword here. We visualize the interactions of the objects in a time sequence, which is different from the activity diagram. The activity diagrams is not in the time sequence at all. It's the flow, okay? It's the flow. But for the interaction diagram, the sequence diagram here, it visualize the interactions of the objects in the time sequence. Okay, that's a key point. State machine diagrams, right? So they are this is one of the behavioral types of the UML diagrams as well. It is used to describe the state in the process. I mentioned before about the state of the washing machine. Okay, when we built the program, washing machine program, right? Normally we start from on off. Okay, turn it on. Start with the washing state, rinsing state, spinning and drying, that kind of thing. Okay, that's the end. Okay, and then it has the power on off, that kind of thing as well. Okay. Okay, so when we use such kind of graphical modeling language here, right, it will facilitate the discussion among the stakeholders as well. It's not just only for the software engineers, but for the software architect, for the customer, for the end users, they may not understand the UI, right? That's another part thing, that's for end users. But if we talk about the business analysts, they have their own expert knowledge to understand what is the business logic inside the software system, so they can verify it as well, whether this is the right step or not, right? Think about a washing machine. realistically, we need to describe the software should follow this kind of state, right? Washing, rinsing, and spinning. Without this kind of diagram, we can implement the software correctly as well. The washing is implemented correctly, rinsing is correctly, spinning correctly, but they are in the different orders. How does it work, right? So we won't get a clean clothes at all. So, you know, so that's why we need the state machine diagram, this kind of diagram, and then the expert, the domain expert or business analyst can verify whether the washing machine perform in the right step, in the right order or not. Okay, all good, everyone? Okay, yep. Okay, so the aims of the requirement analysis, okay, there are three things. First, to deeply understand the requirement. Requirement is just a text, is a high level, is vague, sometimes it's not clear, but once we extract the requirement, model it, everything becomes clear. That's the structure then we understand the structure of the software system and how the software system will behave as well. All right. Okay. Any questions so far? Any questions at all? Before I move on. Nope. Okay, I'll move on now. Yep. Requirement analysis. Normally we will perform 3 steps here. Okay. First thing first, we need to understand what are the features, right? So we will do the functional modeling first. Okay. We will present what are the scenarios of all of the use cases, and what are the artifacts that we want to create as well. That means if you look at the use case diagram here, is a ticket terminal, what's that, ticket terminal, okay, movie, okay, think about cinemas, okay, village cinemas, okay, we want to go to the movies, watch the movies. What do we need to do? As a customer, we want to see the list of the movie names, movie titles, right? That's a choice here. And then we can see the movie details as well. The rating is good or not, that kind of thing. And then we can pre-order the ticket, or we can order the ticket on site as well. That's the 4 basic use case that we need to implement. Let's say if this is for the ticket purchasing system, right? And when we when we look at the movie, when we request the list of the movies at the moment, that kind of feature, that kind of use case can interact with another API as well, another system, which can be movie catalog, right? It can be an external system. And when we purchase the order, okay, Village Cinema may not implement the ordering system by themselves. Maybe they just use the API from the other ordering system, okay? So that can be the external actor as well. Right. And once we identify the use case, these are the features of the software system and who we interact with, then we can come up with the class and the class diagram. That's a class modeling, right? So we determine the class and what are the class, what are the attributes, what are the the not just the attribute, but the action, the methods as well, the behavior of each class. All right, and how do they interact with each other between the classes? So this one is called class diagram. Think about look at this one, right? The person, person can be one of the, let's say person, customer, that's one of the ticket system as well, one class, okay. Well, dynamic modeling, right? So sometimes we can use this kind of dynamic modeling to determine the operations performed by each of the entity class as well. And one of the things that we can create is the state chart diagram, right? When we use the use case, we functional modeling, we know who are the actors, what are the features that and what are the use case that we need to implement, but how the flow works, right? We don't know until we draw the state chart diagram, okay, or the sequence diagram, right? State means like each state. Yeah, okay, that kind of thing. All right, does it make any sense here? Okay, move on. Okay, so functional modeling, it was originated in 19th century within the business operation, and actually it was used in the NASA. Okay, to visualize the time sequence of the event. NASA rocket system is very complex. Without such kind of modeling, I'm sure there's a high chance of failure, rocket failure, right? So that's why we need to be careful about the requirements, design software, design the structure, design the behavior of each of the operation and the step in details. Every little things mean a lot of things. So we need to pay attention to all of the details. And functional modeling is actually useful, but there are some disadvantages as well. For example, it may take a long time to create. And think about like a complex software system that has over 200 functions, right? So that's a very large, very complex, and it takes some time to like create the initial diagram, refine it, make it correct, make it detailed as much as possible, right? So it takes some time, but once you get things right, then you implement the software right. Otherwise, nothing will be correct anyway, right? So, and sometimes when we draw the use case diagram or this kind of functional modeling, the end users may not understand what does it mean, right? Let's say clients would like to get the website for the real estate system, but what we are doing, we just present the class diagram or the use case diagram. Sure, that's the high level, but this is something that may the end users may not want. They may not want to see, right? So, and because this kind of diagrams is drawn in some standard language, which is the UML, right? So it needs you need some expertise and knowledge to understand as well, and you need some expertise to do it well. So every student is expected to understand what is the syntax, the language, the notations of the UML diagram, so you can draw it right in the assignment and in the exam as well. Okay. Yeah, potential scope for ambiguity and imprecision. At the beginning, requirements are ambiguous and imprecise, but it takes some time to translate from something vague, unclear into a very clear picture diagram here. Okay, does it make sense, everyone? Okay, functional modeling here again. Okay, so when we talk about the use case scenarios, right, there are two types of the scenarios. The first one is the normal scenarios, and the normal scenarios just regular scenarios, nothing more than that. What is the set of the interactions between the users and the system? How do they interact with each other in order to achieve the goal? Okay. But there are some exception scenarios as well, or some people call an alternative scenario. Okay, we can call both. And an exception scenario actually describe how to handle an undecided event, which is an event that interferes with the progress towards a goal, right? Think about this one in this figure. Let's say if you want to run in, what is that? What is the park in the CBD? I forget the name. Royal, no, what is the park in the CBD? I live in Clayton too long now. Royal Botanical Garden. Thank you. That's right. Right. So let's say if we run, do some exercise in the Royal Botanical Garden. That's a normal scenarios, right? But sometimes there may be rocks. There may be some large trees that we need to escape it, like don't hit it. So that's the undecided event as well. Or someone want to do the water maintenance or do some construction in the Royal Botanical Garden or plant new trees or that kind of thing. That's the exception, right? It's the undecided event. So when we decide the use case scenarios, we need to consider both, okay? The normal scenarios and the exception scenarios, okay? Okay, walking is one thing, running is one thing, but I try to think about what is that? Okay, okay. Anyway, that's why. Okay. Anyone would like to help me come up with like another software scenarios or not? Normal and the exception. Anyone? Brainstorming, discuss together. Anyone? One more example. Anyone would like to try?
I don't have anything on top of my head.
Pardon? Yes. Who is speaking? I try to find the name. Maybe. Would you like to turn on your video? Okay, no worries. Okay, we can move on. Don't worry. Okay. All right. Yep. Okay, so when we draw the use case scenarios, right, there are some notations, syntax, language that we need to follow. For example, the use case scenario should describe what is the use case name, which should be a short descriptive verb phrase, right? That's the use case name. What is the scenarios? Who trigger it? Okay, who trigger it? What is a brief description? It can be a paragraph that captures the goal of the use case. Who are the actors? And the actors here means that the person who mainly involved in the use case. It can be the initiator or the participant actors, right? Yeah, and what are the related use case? Okay, we can use the three notation that we learned before. For example, they include inclusion, exclusion, generalization. Are there any preconditions, the post condition? What are the flows of the event? And what are the exception conditions? Okay, this is a basic notation that we normally use in the use case scenarios. All right, let's try to do some quiz here. Everyone just go to the flux.qa/6LQDP9, 6LQDP9, and then we will start with first question. Okay. All right. So we receive a few numbers of response now. So, yeah, we got some good number. I would say that majorities of the students can get the right answer, and then I will move on. Okay. Okay. Okay, what are we talking here? So in Moodle, we upload this document, okay, real estate requirement here, right? And I don't know whether everyone has read or not, but let's read together. I use case diagram. Okay, I think let's try to read the real estate requirement here together, and then we're gonna come up with the use case diagram, okay, together as well. Okay, now I think when we want to do the use case diagram, we are talking about the actors and the use case, all right? So we need to identify who are the actors first, okay? The cities of Parallax is one of the most famous cities in the country. The Parallax Council has decided that they need a real estate system to manage property, list, blah, blah, blah. Okay. With real estate agent. Okay. Manage property listed with real estate agents in the city. The system will store records of the properties, blah, blah, blah. Of many. Okay. Okay. I think it will take some time. Let me put this way. So in summary, okay, in summary, yeah, in summary. So once you read this requirement specification of the real estate system, right? Probably you can come up with the two main actors here, which one of them is the real estate agent who can manage the property. That's the first requirement here, okay? Manage the property list with the real estate agent in the city, all right? And what they can do next, that's the optional one, right? It's not mandatory at all. So they can add the property and the update information. What is that? That's the admin. That's another actor, right? Where's the add? Add. Yeah, okay. All right. So the admin can add the property and update the property. The admin, yeah, manage the property, can add the property, update the property. All right. So both real estate agent and the admin can manage the property. That's based on the requirement. Okay, sure. Yeah. And the admin also can manage the real estate company, property agents, print the rent, print the sale, that kind of thing. Okay, that should be written in the below document as well. That's a use case diagram. That's how we draw the use case diagram. And then we need to draw, what is that? Use case scenarios here, right? So we use the template given to create the use case scenarios for the use case. That's a use case, okay? And before you develop the use case scenario, need to consult the client, okay? I think what do we mean is that when you do the assignment, okay, probably when we provide the requirement specification here, it may not be completed, that kind of thing. It's best to consult with your client, and your clients here is your tutors, okay, to find out what are the steps or what are the requirements, what is the detail of the use case scenarios as well. Yeah, you can talk to them, consult with them, all right? And when you do the assignment or draw the use case scenarios, make sure that you cover the exception scenarios as well. That's a must, okay? And yeah, that's all. I think make sure that everything is correct. Okay, all good. Any questions so far? Nope, all good. Okay, so I will move on to the software requirement specification, right? Okay, wonderful. So requirement specification is actually one of the important document as part of the waterfall model or unify or whatever, right? So normally we use it to describe the characteristics of the software system, not just only the functional, but also the non-functional requirement as well. Without the requirement specification, it's very hard for a software engineer to develop a system. If let's imagine, okay, we need a mobile app banking, okay, that's the requirement, right? And then the key question is that how does it look like? What are the features inside the mobile app? Is it viewing the transaction or not? Do we need a login or not, right? So everything needs detail. Without the detail, we cannot implement anything correctly. And think about when you outsource the project, software development projects to the other companies, right? So normally we use the software requirement specification as a contract agreement between the clients and the software engineers as well, the software house, software companies. Okay, so that's very, very important. And what is that? Normally within the software requirement specification, it consists of all of the necessary requirements for the project development. How long does it take? That kind of thing, right? It needs all of the detail, and these are some of the template as well. So if we look at the table of content here, right? Normally we start with what is the purpose of this software system? Okay, mobile app. The purpose is to allow the clients or the end users to access the banking account through the mobile application. Okay, document convention. What is the convention terminologies? Do we any pre-readings for before reading the software requirement specification or not? What is the scope? Are there any reference, right? And then the section 2 we talk about the overall description. What are the general what are the perspective of the product? What are the main features? How what are the user class and the characteristic? What is the operating environment? Whether it is within the Android devices only or the Apple devices as well, or cross-platform, that kind of thing. And design implementation constraints. For example, would the mobile banking application only fits within the what's that, mobile screen size only, or tablet screen size as well, right? So whether it is cross devices compatible or not. And assumptions and the dependencies. Are there any assumptions and the dependencies for that mobile application as well? Okay. System features, that's a functional requirement. We can also, it also can also include the non-functional requirement as well. That's an external interface. For example, what is the UI? What is the hardware interface? What is software? How and whether what is the communication interface to access the mobile app? We need an internet access either via Wi-Fi only, or the what is that, the mobile data 4G or 5G only, right? Are there any non-functional requirements like a performance, safety, security, and software quality attributes? It must be reliable. It must be available during the working hours, but it can be maintained during the night, that kind of thing. Security, does it need like a face detection or not? Safety, whatever, right? Okay. Okay, that's the but when we draw no, sorry, when we document the requirement specification, we need to ensure that it is correct, it's not ambiguous, it must be completed, it is consistent, and it's not conflicted with each other as well. For example, if one part we say, hey, look, the software must be secure, multi-authent is not required, but in the feature requirement, the system must implement the multi-authentication, multi-factor authentication. That's a conflicting requirement. So when we do the requirement specification, requirement elicitation, we need to ensure that it is correct, it is valid as well, right? That's part of the requirement specification. Yeah, we need to verify, yeah, whether the requirements is valid or not. Testing the environment, criteria, everything should be considered or take into consideration. And we should avoid the assumptions as much as possible. We should not say that we assume that think about blind people, right? Some colors blind people cannot see it, so we should not assume that the end users are not blind at all. So we may need to consider that to ensure that the apps are accessible by anyone, right? We need to ensure that yeah, the color scheme of the app should be like should support blind people, that kind of thing. That's an example. We should not assume that, okay, we can choose any color scheme. Okay. All right. Next question. Software requirement specification document is similar to which deliverable? All right, so I'm going to move on to the next part. Okay, so when we do the write the requirement specific as part of the requirement specification, after we document it, we also need to do the requirement analysis, right? So once we get the requirement, we need to identify what are the classes, what are the objects, okay, within the requirement, and then we're gonna diagram modeling it together. Okay, so that's how we do the OO analysis here, right? Okay, what is the object-oriented concepts here? We're gonna talk about that. Okay, we still, yeah, okay. So in the first step, right? Let's go back to this one. We are talking about the 3-step. Where is that? This one, we are talking about functional modeling. We talk about class modeling and the dynamic modeling, right? These are the 3 steps that we're gonna use and apply in the within the unit and during the assignment and the exam as well. We already finished the functional modeling, right? When we get the requirement specification here, okay, think about the city of parallax. We draw the use case scenarios, and now we understand who are the actors, what are the features of the software system, but we don't know how the software is structured. What is the structure of the software system? So that's why we need to do the class modeling to identify what are the classes, what are their attributes, and how do they interact with each other. So that's why we need to draw the class diagram. Okay, class diagram. Here we go. So class diagram are used when developing an OO model, OO software, okay, object-oriented, to show that how each of the class are associated with each other. All right. And when you develop the class modeling here, right? So it normally we do at the early stage of the software development process. And objects should represent something in the real world, such as a patient, prescription, receipt, recipe, or doctor, lecturer, person, employee, student, or whatever, right? So it should be noun. It should not be verb. Okay, it should not be verb. Yeah. Right. Yeah, so this is what we do at the beginning of the software development process. And essentially, these are the essential elements of the UML class diagram, right? In the class diagram, there are class, attributes, operations, relationship, and different types of the association as well, whether it is generalization, composition, aggregation, dependency, or constraint rules or node, that kind of thing. So there are syntax or UML syntax that everyone should know as well. So please try to study it by yourself as well. Okay. What kind of things are the objects? What are the objects here? Objects are nouns, of course, not the verb. Okay, so objects often derive from one of the following sources, originally given by blah blah blah. Last phrase, Grady Bush, and adapt further here. Okay, there's something that is tangible in the real world. So, for example, book, notepad, brochure. What are the roles, right? Library member, student, director of education. What are the events? What are the interactions? These are something that is tangible. Okay. Yeah. Objects, they are similar to real life object as well. It will describe, for example, this one, when we talk about object, this is an animal, right? Each of the object has its own attributes. For example, color, eye, height, length, weight. And they are, each object has its own operation or method as well. For example, this dog, this little dog here can sit down, lay down, shake, come, that kind of thing. Okay, there are some operations that each object has as well. But what is the difference between the class and the object, right? Normally, when we say class is the best one, is the group of the objects here is the best class. But when we so each of the class has its own attribute, operations, that kind of thing, and the relationship. All right. And And when we, but one class can have multiple objects as well. That's the, when we create an object, it will inherit the properties of the base class. All right. Okay. So again, yeah, class here, should the class and method match exactly the entities and attributes in the database? Yes, if we want to implement I think it depends. Class is the class, how we implement the object-oriented program, right? But in the database, it depends, I think, but it is kind of similar. Yeah. You can match, but I think is I would say that most of the time, yeah, the class and the database, they are the same, not real. Yeah, the attributes of the class, okay, should the class and method, not class the method, okay. I would say that it should be class and the attributes. Yeah. Yeah. Yeah, that's right. Yeah. Yeah. Okay. That's right. Thank you. Okay, sure. Yeah, so the class attributes is we talk about the properties and the information that are related to that class. Operation, we talk about the functionality or the behavior of that objects, right? What are the operation? Yeah. And a class is just the commonalities of the individuals, but an object is the one individual with different values. Okay, that's how that's the difference between the class and the object. Is that clear, everyone? Maybe say yes in the Zoom chat. Yes, thank you. Okay, okay, wonderful. All right, and how do we draw the class diagram in the UML language, right? So a class can be represented in the UML notation as well. Normally we use the box. I'll try to get the annotation here. 1 second. Yep. So that's the class. Okay. Of course, there are 3 rows. Okay, 3 rows. The first row that indicate the class name. The second row indicate the attributes and the properties. The third row indicates the operations or the methods, right? If we talk about the dog here, okay, the dog, it has color, okay, color attribute in a string data type. It has height in a float data type. It has length, okay, the length of the dog. In the float data type, it has a weight in the float data type as well. And what it can do is that it can sit, it can shake, it can come, that kind of thing. All right. That's a class diagram. Easy peasy. Okay. So sometimes, right? Ideally, the class model in the UML diagram, it should have three types of the information here: class, attributes, and the operation. But sometimes it may not have as well. So it really depends, right? It's not always necessary to show the attributes and the operation in every diagram. So it depends, but at least the most comprehensive version, it should have 3 data type here. No, so 3 types of the information here, 3 pieces of the information: the class name, attributes, and the operation. Okay. Okay. What do you need to model, right? When we draw the class diagram, of course, we need to draw the class and draw the relationship. Okay, that's and there are 3 different types of the relationship. First is the association, general association. The second one is the inheritance or the generalization. And the third one is the aggregation or the composition. Okay, and I would like to emphasize that this is an iterative process. Drawing a class diagram, it should not be like a perfect one in a one go. You know, it needs some iteration. You need to keep refining it, improving it. So we do not expect to get everything right at the first round. Okay. Okay. What is inheritance and the polymorphism? Oh, all right. Maybe just a question to everyone. Check in the Zoom chat here. Does anyone have some backgrounds about OO concept before, or do you have you heard about inheritance and the polymorphism before as well? Yeah, maybe type in the Zoom chat. All right, thank you. Looks like everyone knows it. Okay, so inherit. Then I can just get to the key point. So inheritance is the way we draw a class in order to inherit the properties of the existing one. Okay, let's say the base class here, right? Okay, we will talk about that later. We will have more examples anyway. Okay, maybe no example for now. Yeah, inheritance is the situation when you want to inherit the properties of the existing class, but the polymorphism is the situation when you want to create multiple classes that perform in different ways. Okay, the same object can have different operations as well. Okay, so that means the polymorphism allows the object to decide which form of the function to implement at compile time as well as the runtime. Okay, it can have multiple functions and the method. Okay, inheritance first. Okay, inheritance. Some people call generalization, right? When we talk about bicycle and the car, both bicycle and the cars are the same thing. It's called vehicle. And there are some common properties that bicycle and the car objects can inherit from the vehicle object here, right? So the common properties here should be the wheels and the gears. And there are three common operations, which is the start, stop, and the turn, all right? When we create a new class, okay, which is called bicycle here, the bicycle class basically inherit the properties from the vehicle. Okay, so that means it has the base properties, base attributes as well. What how many wheels, how many gears, and base operation as well, the start, stop, and the turn. Okay, so bicycle, but when we inherit the base properties from the base class here, the vehicle, right? The inheritance, the new class here that inherit the base one can also has a new or introduce a new properties, the new attributes or the new operations as well. Like in this case, for the bicycle, it has its own handles and the pedals, and but for the cars, right, it has three new attributes: how many windows, how many doors, what is the size of the tank, and it has two new operations as well. We can fill the tank, it can burn, that kind of thing. I don't know what's that burn. Yeah, all right, so that's the inheritance here. Yep, so I should also mention another thing as well. I forget to mention. When we draw the class diagram, right, we talk about the data here. Okay, that's the class name, the attribute, and the operation. Okay, but I forget to mention about plus and minus sign here. So that's the data access permission. Minus is the private and the public is the plus. That means the bicycle can yeah, okay, private and the public, yeah, properties. All good. Okay, shape. All right, that's another kind of inheritance as well. Another example. When we talk about shapes, okay, there are different types of shapes. For example, rectangle, circular, square, or whatever, right? And there are some fundamental basic properties of the shape. The first one could be name. Then there are some basic base operation as well. For example, get name, calculate the area, calculate the perimeter. But each of the each types of the shape can have its own what is that? Its own calculation. So that's why rectangle here, right? When we draw here, rectangle inherit the base property, inherit from the shape, which is the base class. It has two new attributes, which is height and the width, and it has two new operations as well, which is calculate the area and calculate the perimeter, which these two, let me get the draw here, okay? These two here can override the basic operation from the base property as well. It can override. It can have its own calculation, its own formula. All right. Make sense, everyone? Okay. Thank you. No issue. Shape class, okay, and this is when we draw that diagram, right? But if we want to translate into the Java program, this is what we will do. Normally, we just create a class shape in a public, okay, type here, and then when this part is the attributes, right? We create the name here. No, sorry, not just only the name, okay. So that's the class name, shape. This is the attribute, okay, and we declare it as private. So if the superclass member are defined as private, the subclass cannot access them. Right, that's right. Okay, so that's the class name, and the public, the subclass can access this one, access the get name to return the name. Okay, and we can define the this is a shape class. It has the base operation, calculate area, and calculate the perimeter, right? Just return 0 because different shapes have its own calculation of formula. So that's why we don't define it here. And when we inherit the right? Inherit the, so we will say like this: public class square extend rectangle like this, okay, and then we can define what is the square here as well, okay. There's a constructor, and the input is the double side, which return two side here like that. Okay, all right. Okay, just a summary here, right? So basically, we use the inheritance to reduce the development time. Actually, it will increase the reusability will increase the maintenance aspect of the software system as well, because we don't duplicate the code multiple times, right? And then when we change one part of the software, it will be all done. We don't need to like the code will not be redundant, and we don't need to change like everywhere as well, even if you want to change something. All right, and what else? What else? What else? What else? What I want to say? That's all. Okay, maybe I'll just jump to the polymorphism here. Any questions before I move to the polymorphism? Nope. Oh, good. Okay. Thank you. If you have any other questions during the workshop, everyone can ask the tutors as well. Okay, just in case. And polymorphism, what is that, right? In the Greek words, actually poly means many, and morph means form. That means form or shape, right? So polymorphism means that something can occur in many different forms. Okay. And polymorphism is the ability of an object that can take on many forms here. And we normally use the polymorphism in the OOP when a parent class reference is used to refer to a child class object, right? Let me try to get an example here. No example yet. Let me see. Polymorphism, okay. Yeah. So polymorphism is kind of like an extension, right? So let me put this way. Polymorphism is different from the inheritance. When we have the base class, we create a new class that inherit the base properties. That's inheritance. And then we can modify, extend, add new attributes or the operation to the new object as well. That's an inheritance. But for the polymorphism here, right, we want to create a new class that have the same same operation, but we have in different ways. Okay, like in this example, we create a new the animal is the base class here. Okay, and it has the basic properties, for example, animal sound, that kind of thing. But the animal here, okay, animal we can have there are different types of animal. Okay, for example, pig, dog, and each of the animals can have different sound as well. So when we create a new class, we can modify the property inside as well, right? So in this case, the animal is the superclass, and pig and the dog is the subclass here. Okay, does it make sense? Okay, I hope all good. Okay, and this is another example. Let's say if we want, let's say this is a company, okay, a company, and one company has different employee, and different employee has different types of the employee, right? Like for example, full-time salary employee, the salary which is get the salary based on the commission. Let's think about the sale associate, sale agents, that kind of thing, or a casual contract like an hourly based employee. Okay, so that means in this case, when the employee is the superclass here, that's the base property. We define the common properties, common attributes, common operation, and each type of the employee can have, we can create a subclass here. Salary employee, different types of the employee as well, that inherit the common properties of the employee. Okay. Okay, what's this? Okay, that's the polymorphism again, right? In the animal here. Okay, so as I mentioned before, that let me get the draw. Okay, polymorphism animal, we have this one, okay, as a base, and the operation animal sound will return the animal makes a sound, but this is a general sound for every animals. But when we create a class that extend the animal properties, okay, so we can modify the behavior of that object, customize in our own way as well. So instead of saying the animal makes a sound, for the pig, we can say that the pig says VV, okay? And class dog extend the animal, public void animal sound here, right? So for the dog class that extend the animal, it can has its own sound as well, bow bow, something like that. Okay, that's a polymorphism. Okay, so just to recap here, when we use the polymorphism, the object use the method to communicate with each other, and another object could execute the following code to communicate with a circle by using the calculate area method here as well. For example, what is that? Draw. Okay, get the draw. We create a new object here, right? Create a new circle, 5 here, okay? Most likely maybe some value, okay, that we use to calculate the area in the variable a circle, and we want to return the calculate area here to the area. Okay, so it will get something. Okay, but this kind of common property can be used in the other types of the object as well. For example, the square, the rectangle, the circle, but it can we call the same method name, but the return results will be different. It depends on how we program it. Okay, this is called polymorphism. Makes sense, everyone? Yes. Okay. All right. Okay, abstract class. Okay, so when we talk about the abstract class, it means that we sometimes we don't know, we just make it abstract, right? It is a super high level, and it may not have a clear value of the attributes or the operation as well. And later on, we can inherit the abstract class and then modify it, make it clear later as well. Think about the what is that? Animals again, right? So at the lowest point here, okay, we may have dog, okay, dog, cat, maybe rat, okay, which is which inherit the abstract class here. Animal, okay, animal. But if we want to go crazy, right, we can even say that, hey, look, in reality, it's not just only animals, but actually here we are called mammals, right? And mammals, and maybe we have another class which is like a non-mammals, okay, non-mammals, and everything we just abstract more and abstract more, and then it becomes animal. If we want to get another layer, and non-mammals, we can say what is that? Fish, okay, fish, shrimp, for example, okay. Oh, looks like I'm hungry now. Okay, what is that? What else? Okay, octopus, okay. That's the non-mammals, that kind of thing. That's how we abstract everything, right? And the base property here for the animals, what is that? What it should be? Probably name, and everything should has probably the common property, maybe weight, right? Weight and the height, the size, that kind of thing. Okay. Yeah. And mammals, it can have like legs, arms, whatever. This one, it can be something else as well. This is an example of the abstract class. We try to abstract as much as possible, and the rest of them we will call the subclass here. Okay. All good, everyone? Okay, shape again. Yeah. So this is an example of the abstract class when we when we implement it in Java, right? We just use the term abstract, okay? That's the best class here. And in Java, what is that here? Abstract method in Java have no method body and are terminated with a semicolon after the declaration. That's a basic implementation wise in the Java programming language. So classes, at least one abstract method must be declared as abstract. Okay, like this one, we use the keyword abstract, right? And the abstract method from a superclass must be implemented in the subclass. Otherwise, Java will give an error message. Okay, that's the mandatory one. Both methods in the shape abstract class must have a body or declare as abstract in the circle and rectangle subclass here. Okay, that's the thing. Circle class, public class circle extend the shape. Okay, we have the abstract, the shape here, which is the abstract class, and then we are going to extend it, right? Extend as a circle. All right. Circle, I'll get the draw again. Okay, circle, extend the shape, and then we declare new attribute here as a private. Okay, radius, circle should have its own radius. Okay, radius, this is a radius. And public class double radius. Okay, that's a constructor to assign radius, this one, okay, as radius here, okay. And then because we the abstract class, no, sorry, because the shape is declared as an abstract class, we need to override it. So we use the annotator here, okay, at override. The public double calculate area. So, okay, pi to the power of, what is that? Math pi, okay, pi multiplied by r square, okay? That's the constant in the math class. Yeah, okay. So that's how we calculate the area and calculate the parameter. Okay. So we just override the base property again, 2 pi r. Okay. All done. Clear. Easy. Okay, rectangle is the same. I think the concept is the same, right? Maybe I don't need to explain. Yeah, I think we can skip. Okay, any questions so far? Yeah. If not, then maybe we move to the next flux question. All right. Okay, thank you. I think all good. So, okay, we are in the summary now. Oh, the time flies very fast. Okay, in summary, in this lecture, right, we talk about the system modeling. We are talking about the once we get the requirement specification document, we will do 3 steps: do the functional modeling, class modeling, and dynamic modeling. Okay, we will talk about the state machine diagram later as well, and then I think that's all. We will so next week we'll talk about the unified process, agile, and the teams, and the week 5 we will come back with the class modeling in more details as well. Okay. Wonderful, everyone. Thank you so much for your attention, and I hope everyone will enjoy the rest of the day. I will just wrap up the lecture with the reference. You can see more details, study more. I hope everyone, try to do the self-study by yourself, how to do the draw the UML diagrams correctly, right? Okay, all done. If you have any questions, please feel free to ask on the ED STEM as well. Okay, see you everyone. Bye-bye.